All right, so heat pumps in China, huh? Looks like we've got quite a bit to dig into today. We've got excerpts from this IEA report, The Future of Heat Pumps in China.
Co-authored, I might add, by experts from both the IEA and Tsinghua University's Building Energy Research Center.
Oh, very cool.
Yeah, should be interesting.
So what's the mission for this deep dive?
Well, we're going to explore the potential of heat pumps to, decarbonize heating in China's buildings and industries. And we'll also be looking at the implications for, a bunch of things: environment, public health, supply chains, jobs, investment needs, electricity systems, even innovation.
Wow, sounds like a pretty comprehensive look. Maybe we should start with just a basic overview of heating in China. What's the current state of things?
Well, heating in China is a major energy consumer. We're talking about 1/3 of global energy use and 1/4 of global energy-related emissions.
Whoa. Just for heating?
Just for heating. It's massive. To put that into perspective, imagine all the energy used to power homes, businesses, and transportation around the world combined. 1/3 of that goes just to keeping people warm in China.
Wow. And I'm assuming most of that's from fossil fuels.
You are correct. In 2022, a whopping 70% of China's heating relied on fossil fuels. That's double the heat consumption of their entire buildings sector.
Double? Wow. That's a massive amount of fossil fuel consumption. Really puts into perspective how important China's choices are for the whole planet, not just them.
Absolutely. If China can successfully transition to cleaner heating solutions, it'll have huge implications for global climate goals.
Okay, that 70% number is a real eye-opener. But before we get too deep into solutions, you mentioned buildings playing a key role in all this. Can you expand on that a bit?
Sure. So while industry has a big overall demand for heat, about 60% of the demand for heat below 200 degrees Celsius, which is a temperature range suitable for heat pumps, actually comes from buildings.
Huh. So even though we tend to think of factories and stuff when we talk about energy use, buildings are a big factor too.
Absolutely. Addressing heating emissions from buildings is critical for China's decarbonization strategy.
That makes sense. Now, the report also mentions some issues with heating data globally. Can you tell us more about that?
Yeah, that's a significant challenge. Basically, there's a lack of consistency in how heating statistics are collected and reported around the world. This makes it difficult to accurately assess the problem and, develop effective policies. The IEA report really emphasizes the need for better data, harmonization to get a clear picture.
So it's like trying to solve a puzzle with some pieces missing. You need that accurate data to really understand the scope of the problem.
Exactly. Accurate data is the foundation for taking meaningful action.
Okay, so we've got this huge demand for heating in China, mostly from fossil fuels, and we need good data to guide our solutions. Speaking of which, heat pumps, right? Those seem to be the main focus here.
Right. Heat pumps offer a really promising way to decarbonize heating, both in buildings and industries.
Okay, so for those who might not know, what exactly is a heat pump?
Well, essentially, it's a device that can transfer heat from a colder area to a warmer area using a refrigerant. And the cool thing is they can be used for both heating and cooling, so they're super versatile.
So instead of generating heat directly, they're just moving existing heat around. Sounds pretty efficient.
It is, and that's why they're so promising for decarbonizing heating.
Okay, so how do they actually work to decarbonize heating? Let's start with buildings.
All right, so for buildings, it's a two-pronged approach. First, reducing the demand for heat.
Okay, that makes sense. Less energy needed overall means less reliance on those fossil fuels. How do we reduce heat demand in buildings?
Well, there are several strategies. Efficient building design is key. Think better insulation, windows that minimize heat loss, and even things like building orientation to maximize passive solar heating.
So basically designing buildings that are more energy efficient from the ground up.
Exactly. And we also need to look at retrofitting existing buildings to improve their energy performance as well.
Yeah, especially since the report mentioned that a lot of China's existing buildings will still be around in 2050.
Right, exactly.
And what about individual behaviors? Can people contribute to reducing heat demand?
Absolutely. Simple things like adjusting your thermostat a few degrees can make a difference. Maybe wear a sweater indoors instead of cranking up the heat.
I like that, finding that balance between comfort and conservation.
Exactly. And on those colder days when you need more heat, we can use heat pumps in conjunction with other smart technologies to make the system even more efficient.
Okay, so it's about using technology to be smarter about heating, not just relying on cranking up a thermostat. What kind of smart technologies are we talking about?
Well, think thermal networks and energy storage. Thermal networks allow for efficient distribution of heat, while energy storage can help manage electricity demand by, say, storing heat during off-peak hours and releasing it when needed. This helps to ensure grid stability even when everyone's using their heat pumps.
So it's not just about individual heat pumps. It's about integrating them into a smarter, more interconnected system, like a team of technologies all working together.
You got it.
This all sounds great for buildings, but what about industries? They often need much higher temperatures for their processes, right?
That's right, and that's where it gets a little more complex. Heat pumps are great for processes below 200 degrees Celsius, but many industries need much higher temperatures than that. For those hotter applications, we'll need other technologies.
So it's not a one-size-fits-all solution. What are some examples of those other technologies for high-temperature industrial processes?
Well, a few options are being explored, things like induction heaters, electric arc furnaces, even hydrogen and bioenergy heaters.
So finding the right tool for the job, depending on the temperature needs. But even with those other technologies, heat pumps still have a big role to play in industrial decarbonization, right?
Absolutely. Remember, a big chunk of industrial processes actually occur below that 200-degree threshold, making heat pumps viable for a good portion of their needs. And there's another area where heat pumps can have a huge impact: China's district heating systems.
You mean those networks of pipes that carry heat to multiple buildings? Didn't you say those mostly rely on fossil fuels right now?
Yes, especially in northern China. But that also means they offer a huge opportunity for large-scale decarbonization by integrating heat pumps, renewable energy, waste heat recovery, and smart storage.
Turning those district heating systems into clean energy hubs. That's a pretty cool concept. But before we go deeper into district heating, I want to circle back to buildings for a second. The report painted a pretty bleak picture of their emissions. Can you elaborate on that?
Sure. Emissions from space and water heating in China's buildings have actually tripled since 2000. This is driven by a massive boom in construction and a shift to commercial fuels in rural areas.
So more buildings A&D, more reliance on fossil fuels, not a great combo. Does China's diverse climate play a role in heating choices?
Oh, definitely. The vast differences in climate across China mean that different types of heating systems are used. For example, in northern China, with its harsh winters, district heating is the dominant system. But in the southern regions, where winters are milder, decentralized heating systems like individual heat pumps are becoming more common as living standards rise.
So different climates, different solutions. The report also talked about how crucial it is to address emissions from existing buildings. Why is that?
Well, get this. A whopping 75% of China's current building stock will still be standing in 2050. So we can't just focus on new construction. We need to find ways to make those older buildings more energy efficient.
It's like a nationwide home renovation project, but for energy efficiency.
Exactly. And heat pumps offer a great option for retrofitting, especially for buildings that aren't connected to those district heating or gas networks.
Okay, so we've got a good idea of the potential for heat pumps in buildings. What about their use in industries? Is there a similar opportunity there?
Absolutely. Remember we talked about industries being massive energy consumers? Well, heat accounts for about 60% of their energy demand. And even though China's made progress in reducing the emissions intensity of their industries, those absolute emissions are still going up. They're getting more efficient, but they're also producing more, which means higher overall emissions.
It's a bit of a catch-22 then, isn't it?
It is. But here's some good news. 60% of that industrial heat demand falls below 200 degrees Celsius, which, as we discussed, makes heat pumps a real possibility for a lot of those processes.
So there's a big opportunity there. Which industries would benefit the most from heat pumps?
Light industries like food processing and machinery manufacturing are great candidates because their processes generally need lower temperatures. But here's the kicker. Only a tiny fraction of Chinese industries actually have heat pumps installed right now.
Wow. Talk about untapped potential. Seems like China's just starting to explore the possibilities of heat pumps for their industries.
Exactly. There's huge room for growth in this sector.
Okay, so we've got buildings and industries, both with a need for cleaner heating solutions. Now, let's circle back to those massive district heating systems we touched on earlier. How do heat pumps fit into that picture?
District heating, especially in northern China, offers a unique chance to integrate heat pumps on a really large scale. And while the global market for those large-scale heat pumps and district heating is still pretty new, China's taking the lead with a bunch of demonstration projects.
So China's on the cutting edge of this tech. That's pretty exciting. How do they actually integrate these large-scale heat pumps into their existing networks?
Well, it's all about flexibility. These heat pumps can be connected at different points in the network, which makes the whole system more adaptable and efficient.
Got it. So it's not just about plugging in a heat pump, it's about strategically placing it for optimal performance. The report also mentioned something about lowering district heating temperatures. Why is that important?
Lowering those temperatures has a couple of big benefits. It cuts down on energy losses within the network, and it makes it much easier to incorporate renewables, waste heat recovery, and you guessed it, heat pumps.
Creating a more efficient A&D flexible system. This is making me think about all the heat that just gets wasted, released into the atmosphere from different sources. Couldn't we somehow capture and reuse that heat?
You're talking about waste heat recovery, and you're absolutely right. It's a fantastic way to boost the efficiency of those heat pumps even more. And guess what? China has a ton of waste heat below 100 degrees Celsius, the perfect range for heat pump utilization.
That's incredible. Where's all this untapped heat coming from? What are the main sources?
Thermal power plants are a big one.
Yeah.
But we've also got industries, data centers, even wastewater plants generating significant amounts of waste heat. By 2050, China's going to have access to almost 20 exajoules of waste heat, enough to power a whopping 650 gigawatts of heat pump capacity. That's like 20 times the potential in light industries.
Whoa, those numbers are mind-blowing. So we've got all this free heat just waiting to be tapped into. What's stopping us from using it more?
Well, there are some hurdles. Economic challenges and a lack of coordination among stakeholders are the main obstacles. It can be hard, especially for smaller industrial players, to make a strong economic case for investing in waste heat recovery.
So it sounds like we need some policy support to get over those initial barriers and unlock all that potential. What are some potential solutions?
You're right. Government incentives and policies could really be game changers. Providing financial assistance, especially for smaller industries, could make those waste heat recovery projects a lot more appealing.
That makes a lot of sense. It seems like waste heat recovery is a crucial piece of the puzzle when it comes to maximizing the potential of heat pumps in China. But beyond the technical stuff, what are the wider implications of increasing heat pump use across the country? What are the potential benefits and challenges?
That's a great question, and it's something we'll dig into more in the next part of our deep dive.
All right, so stay tuned as we explore the ripple effects of heat pump adoption in China, from environmental and public health impacts to economic considerations and even the challenges for electricity systems. We'll be right back.
So before the break, we were talking about waste heat recovery. Huge potential there.
Right, really interesting stuff. But let's zoom out a bit. What are some of the broader implications of ramping up heat pump deployment in China?
It's multifaceted. Impacts everything from the environment and public health to economics and even the electricity grid.
Okay, let's start with the positives. How would more heat pumps impact the environment?
Well, first and foremost, they can drastically reduce CO2 emissions compared to, fossil fuel heating systems. That's essential for tackling climate change.
That's a big win for the planet.
Right.
But it's not just CO2, right? What about other air pollutants?
Right. Heat pumps are great at reducing those too, especially compared to those old coal-fired boilers that are still pretty common in China. Cleaner air, fewer respiratory problems. It's a win for public health too.
So cleaner air, A&D, a cooler planet. Pretty impressive. But didn't the report also mention some concerns about refrigerants used in heat pumps?
Yeah, that's an important point. Some refrigerants can actually contribute to global warming if they leak into the atmosphere.
That's a bit of a paradox, isn't it? We're trying to reduce emissions with heat pumps, but they could potentially leak harmful refrigerants.
It's a valid concern, but the good news is the industry is moving toward low GWP refrigerants. Those are refrigerants with a lower global warming potential. So the risk is being minimized.
So we need to make sure we're using the right kind of refrigerants. And what about preventing leaks?
Proper handling is key during manufacturing, installation, maintenance, and even decommissioning. Minimizing those leaks throughout the entire life cycle of the heat pump.
So making sure they're built and handled responsibly from start to finish.
Exactly. Now, shifting gears a bit, we also need to think about the impact of widespread heat pump use on the electricity grid.
Right. If everyone's plugging in their electric heat pumps, won't that put a strain on the grid, especially during those freezing winter months when heating demand is highest?
That's definitely a challenge. We could see those peaks in electricity demand during those cold winter evenings, especially if it's super cold and everyone's using their heat pumps at the same time.
So how do we make sure the grid can handle it?
It'll take careful planning and investment. Modernizing the grid is crucial. as is increasing renewable energy capacity to meet that growing demand. And we need to implement demand response mechanisms.
Demand response. What's that?
It's a way to encourage consumers to use electricity during off-peak times. For example, preheating your home in the afternoon when electricity demand is lower and maybe solar power is abundant, so your heat pump doesn't have to work as hard during the evening rush.
That's a clever way to balance things out, being smarter about how and when we use electricity.
Exactly. And of course, ongoing improvements in energy efficiency in buildings' A&D appliances are crucial to reduce overall consumption.
All right, so we've talked environment and the grid. Now, what about the economic side of things? China's already a big player in the global heat pump market, right?
They are. China manufactures something like 35% of all heat pumps sold worldwide, and their fastest growing export segment is air-to-water heat pumps. That's driven by huge demand in Europe, which is also working hard to, clean up its heating sector.
So they're supplying both domestic A&D, international demand. That's impressive, but scaling up production even further is going to take a lot of skilled workers, right?
Absolutely. That brings us to the job creation potential of the heat pump sector. As China ramps up deployment, they'll need more skilled workers. Manufacturing, installation, maintenance, even R&D, lots of opportunities.
So it's not just about building and selling heat pumps, it's about building a whole ecosystem of jobs and expertise.
Exactly. Win-win for the economy and the environment.
Speaking of economics, let's talk cost. Heat pumps aren't exactly cheap, are they?
That's true. The upfront cost of a heat pump can be a hurdle for some folks, especially compared to, those traditional systems. It is a bigger initial investment.
But don't they save money in the long run because they're more efficient?
They absolutely do. A heat pump will usually pay for itself over time thanks to lower energy bills. It's an investment that pays dividends for your wallet and the planet.
Good point. So it's about taking that long-term view. But still, those upfront costs can be tough for some households, especially those on tight budgets.
You're absolutely right. And that's where government policies can really help making heat pumps more accessible and affordable for everyone.
Okay, so what kind of policies are we talking about? What can the government do to help boost heat pump adoption?
The IEA report has a bunch of recommendations, promoting those large-scale building retrofits, phasing out fossil fuel subsidies, raising awareness about the benefits of heat pumps, supporting research and development, and of course, driving that waste heat recovery we talked about.
So a mix of incentives and, disincentives, making the clean option more attractive and the polluting options less so.
Precisely. We also need better data oversight, clear deployment targets, programs to create jobs in the heat pump sector, and stronger energy efficiency standards.
Sounds like a whole government approach, really. Lots of moving parts.
You got it. And international collaboration and knowledge sharing are super important too. Learning from other countries that have successfully implemented heat pump programs, working together to overcome those technological hurdles, it's a global effort.
Collaboration is key. Okay, let's focus back in on buildings for a sec. The report had some specific recommendations for making heat pumps more popular in that sector, right?
Right. One suggestion was to encourage those large-scale building retrofit packages as part of a coordinated heat pump rollout.
So not just replacing individual systems here and there, but a more strategic approach, tackling multiple buildings in a neighborhood or district at the same time.
Exactly. Economies of scale, making the whole process more efficient.
Makes sense. And what about those fossil fuel subsidies we mentioned?
The report is pretty clear, phase them out. And ASAP.
Yeah, why use taxpayer money to support old, polluting tech when we've got cleaner alternatives ready to go?
Exactly. Those funds could be redirected to support heat pumps and other clean energy solutions.
It seems obvious when you put it like that. But what about folks who might still be hesitant to make the switch to heat pumps? Maybe they've heard some myths or misconceptions about the technology.
That's where public awareness campaigns come in. We need to educate people about the benefits of heat pumps for their wallets, A&D for the environment.
Bust those myths, highlight the advantages.
Exactly. And make sure those heat pumps are installed correctly so they actually perform as well as they should.
That's a good point. Bad installation could really negate all those potential energy savings.
Absolutely. Quality control is essential. Strengthening those energy efficiency standards for heat pumps, making sure installers are properly trained and certified, it all matters.
Right, getting it right from the start to maximize those benefits. Speaking of clarity, the report also talked about the importance of clear labeling, right?
Yes. It can be really confusing for consumers to compare different heat pump models and understand their energy efficiency.
So making sure those energy efficiency labels are clear, consistent, easy to understand. No more fine print.
Exactly. Informed consumers make better choices.
Okay, let's shift gears and talk about industries. What are some of the key recommendations for encouraging them to adopt heat pumps?
Well, one thing that stuck out to me was the need to just raise awareness among those industry decision makers.
Making sure they understand the potential of this technology.
Right. A lot of them just aren't aware of the benefits of heat pumps, or they might not know which type of heat pump would best suit their specific needs.
So more information and guidance is needed.
Exactly. The report suggests creating a dedicated information and knowledge base specifically for industrial heat pump integration. Basically a one-stop shop for everything heat pump related for industries.
That sounds really useful. But information alone might not be enough to convince some industries to make the switch, right?
That's true. Some industries are understandably a little hesitant to jump into new technologies, especially if their current processes seem to be working okay.
So how do we get past that hesitation? How do we convince them to give heat pumps a shot?
That's where research and demonstration projects can really shine. They can show the real-world benefits of heat pumps in action in different industrial settings. Seeing is believing.
Right. So showing, not just telling. Seeing those results firsthand can be really persuasive.
Exactly. And those demonstration projects also give us valuable data and insights that can then be used to refine the technology and make it even better. It's a win-win.
Love that. Learning by doing. But even with all these benefits, that upfront cost can still be a barrier for industries, just like for households.
You're right. And the report recognizes that, recommending policies to ease that burden.
So what kind of policies could make heat pumps more affordable for industries?
One idea is to offer targeted financial incentives, things like grants or low-interest loans, specifically for installing heat pumps in certain key industries.
Taking some of the sting out of that initial investment.
Exactly. Another idea is to offer tax breaks or other financial rewards for companies that adopt the technology.
Again, using both carrots and sticks to encourage those good choices.
Exactly. Now, something that's often overlooked in these discussions, data.
Data, what do you mean?
The report was really big on the need for good data oversight when it comes to heat pump deployment.
Right. I can see how having good data would be useful to track progress and figure out where we need to improve. But why is it so important?
Without good data, it's tough to make smart policy decisions. We need data to know what's working, what's not, and where to focus our efforts. Without it, we're just shooting in the dark.
Okay, yeah, makes sense. So what kind of data should we be collecting? And how do we even go about getting it?
Well, we need data on sales, installation rates, energy savings achieved, the types of heat pumps being used in different regions and industries. We can collect this through industry surveys, government monitoring programs, and even by using some of those smart technologies we discussed.
Using every tool in the toolbox to gather those insights.
Exactly. And then once we have that data, we use it to make better decisions, refine policies, target incentives more effectively, pinpoint areas for improvement, and track our overall progress.
So it's about taking action based on those data-driven insights.
Exactly. Data helps us go from those big, vague ideas to concrete results. Speaking of concrete actions, another way to really push for heat pump adoption is setting targets.
Targets? Like goals for how many heat pumps should be installed by a certain time.
Exactly. The report recommends China set those quantitative targets for heat pump deployment in both buildings and industries.
Why are those targets so important?
They create a sense of urgency and give everyone a clear roadmap for action. And they signal to the market that the government's serious about heat pumps, which encourages investment and innovation. It's about putting your money where your mouth is.
So setting those clear expectations and getting everyone on the same page, working towards a common goal.
Exactly. And those targets also help us hold ourselves accountable. Are we actually making progress? Are we on track to meet our goals? It keeps everyone honest.
Turning those aspirations into measurable results.
You got it. Now, let's shift gears again and talk about something I'm passionate about, jobs.
Right. Earlier, we talked about how the heat pump sector could create a lot of jobs. What specific recommendations did the report have on that front?
It emphasized the importance of promoting job opportunities and skills development across the board. Everything from manufacturing to installation to operation and maintenance, the whole shebang.
So, building up that skilled workforce that can support this transition to heat pumps.
Right. Investing in vocational training, certification programs, educational initiatives to get young people interested in this field, it's about planting those seeds for a sustainable future, for the environment, and the workforce.
I love that. It's about looking ahead, making sure people have the skills they'll need to thrive in this cleaner, more sustainable future.
Exactly. But we also need to consider those workers who might be displaced from those traditional fossil fuel-based industries. We can't leave them behind.
Right, ensuring a just and equitable transition.
Absolutely. It's about creating a future that's both sustainable and equitable for everyone. No one gets left behind.
Okay, we've covered a lot of ground in this deep dive, the technical aspects, the policy implications, the economic and social impacts. It's a pretty complex topic, but we're starting to see the big picture.
We are. And what we're seeing is that heat pumps aren't just some random technology. They're a potential pathway to a cleaner, healthier, and more sustainable future. Not just for China, but for the whole world.
It's exciting to think about the possibilities. But before we get carried away, let's bring it back to China and those massive district heating networks we were discussing.
Right, they're a huge opportunity, but they also present some specific challenges that we haven't fully explored.
Like how exactly to integrate those large-scale heat pumps and how to manage those peak demand periods in winter.
Exactly. And that's what we'll be diving into in the final part of our deep dive.
So those district heating networks, especially in northern China, huge potential for decarbonization, but also some unique challenges.
Right, exactly. Yeah. Those networks, they're a great opportunity to really scale up clean heating, but it'll take some careful planning and smart solutions to make that transition smooth.
One challenge we talked about was managing those peak demand periods, in winter, when everyone's cranking up the heat, if everyone's running their heat pumps on a really cold day, how do we make sure the electricity grid can handle it?
That's a key question. The IEA report recommends a strategic approach, basically rolling out heat pumps in a way that aligns with the expansion of renewable energy. So as we electrify heating with those heat pumps, we're also boosting the supply of clean electricity to power them.
Makes sense. We don't want to end up just swapping reliance on fossil fuels for a dirtier electricity grid.
Exactly. Got to make sure the growth of one supports the clean energy transition of the other.
It's all connected. But what about those times when renewable energy production dips? Like, say, on a freezing winter night when the sun's down and the wind's not blowing. How do we make sure there's enough heat, even when those renewables aren't available?
That's where energy storage comes in. Investing in technologies that can store that excess renewable energy generated when it is plentiful, like those sunny or windy days, and then release it when we need it most, like those cold, dark nights.
Like a giant battery for the heating system, storing up energy when it's abundant and releasing it when demand spikes.
You got it. A thermal savings account for those cold snaps.
Love that. What kind of technologies are we talking about for this large-scale energy storage?
Well, there are some promising options out there. One is those large-scale thermal energy storage systems. Think massive insulated water tanks or even underground caverns that can hold all that heat.
So capturing and storing that heat when it's available and then releasing it when it's needed. A smart way to fill in those gaps in renewable energy production and make sure there's always enough heat regardless of the weather.
Exactly. And these storage systems don't just benefit the heating sector, they can also help balance out the electricity grid, smooth out those peaks in demand, and make the whole system more stable and resilient.
It sounds like a win-win for both heating and electricity. They can actually work together to build a more sustainable and reliable energy system. Well, we've covered a lot in this deep dive. The technical details, policy ideas, the economic and social implications. It's been a fascinating journey. What's the biggest takeaway for you?
For me, it really boils down to this. China is at a crucial point when it comes to heating. The decisions they make now are going to have a huge impact, not just on their own carbon neutrality goals, but on the global fight against climate change. What they do affects everyone.
It's a pivotal moment with a lot riding on it.
Yeah.
But it's also an exciting time, full of possibilities.
Absolutely. China has a real chance to become a global leader in clean heating technologies. And as we've seen, heat pumps can be a major part of that transition.
It's inspiring to think about all the innovation and progress that could happen in this sector.
It is. And those heat pumps we've been talking about, they're not just a technology. They're a real, tangible step toward a cleaner, healthier, more sustainable future.
A future that takes collaboration, innovation, and making those tough choices today so we can have a better tomorrow.
Couldn't have said it better myself. And this isn't just about China. The lessons learned here, the challenges they overcome, the innovations they develop, those can benefit everyone. Other countries can learn from China's experience as they work towards their own clean energy goals.
It's a global effort. Well, this deep dive has given us a great overview of the potential of heat pumps, not just in China, but around the world. And as we've seen, it's going to take all of us, governments, businesses, researchers, everyone working together to make this clean energy future a reality.
You said it. We've just scratched the surface of this topic, but hopefully we've piqued your interest and given you some things to think about. Where do you see the biggest opportunities and challenges for heat pumps? Let's keep this conversation going.